Hey, so I would like to talk about the electromagnetic spectrum today. And to discuss that, I think we also need to discuss the sun. So we all know what the sun is. We know it's that shiny thing that we see every morning or in the afternoon, right? That gives us sunlight. But then what we actually get from the sun is the complete electromagnetic spectrum. And what is that spectrum? That spectrum is basically just a range of different wavelengths, right? For now, think about it like it's a group of information. And only less than 1% of the information we get from the sun is what we know as visible light. So everything you see, the information you get that enables you to see is only less than 1%. Then that raises the question as to, okay, so what is the remaining 99%? So the other 99% of the information we get from the sun, right, belongs to the other subgroups of the spectrum. And these groups have names. Some of them are gamma rays, X-rays, infrared light, microwaves, and what we previously discussed, visible light. But now I'd like to talk about microwaves. In most households, there's something called a microwave oven. It's not a microwave, it's a microwave oven. The microwave name, part of the name, just refers to how heat gets transferred to your food. And in fact, there is something called a magnetron inside the microwave oven that generates the microwaves that then heat up your food. But then the question you might want to ask is, why does it heat up the food but then not the body of the microwave itself? Right? So just to make sure the food is hot, let's check this. So the average temperature of the room right now is 25 degrees. And the temperature of the water now is... So it's about, so it's 98 degrees. So why is the content of this bowl 98 degrees, but the body of the microwave is not anything close to that? Because if it was, then I would have burnt my hand, right? So that's because of something called radiation. It's the same way we get heat from the sun, actually. The sun doesn't directly apply heat on us. It radiates all that spectrum that we've talked about, that information, it radiates it towards us, like to Earth. Then that radiation is transferred to heat energy in our bodies. So that's exactly the same thing that goes on here. So the magnetron generates the microwaves. They come out through these holes here and they go all the way to the end of the microwave. So during the transfer, food, usually containing like water or fats, absorb that energy. They convert it to kinetic energy, and then that becomes heat. And so that's the actual process of how your food gets hot. And that's why, like, the glass itself or the body isn't hot, and why I can still touch it, because they don't absorb the waves. And then the reason the microwave has to spin, the microwave oven, rather, the tray on the microwave oven has to spin. So the reason why the plate has to spin is because the waves go in one direction. They only go across one way. They don't bounce around the oven. So you want the plate to move around so that all areas of your food absorb those microwaves and then heat gets applied. So knowing this explains properly now why sometimes you have a hot plate but then cold food. Because even though the microwaves go from this end to that end, if you have a lot of food, the microwave might not be able to penetrate through to the middle. So only the ends, the food on the end of the plate, gets heated, right? So that's why you have situations where you have a hot plate, but then the food in the middle is still cold. That's because the microwaves never actually got to the middle yet. Or why you have situations like if you microwave pizza, or if you microwave bread, you see like the plate becomes wet because the water and fat molecules in those particular foods are moving around. So it makes sense that you see them on your plate also. So two more things I want to point out here are the power output and the frequency. So as you can see, the output for this particular microwave is 1000 watts, and that's a lot of power. So in any situation where your microwave stops working or isn't working properly, try and replace the microwave. You don't want the waves like escaping. That could cause issues later on. Something else I want you to point out is the frequency. As you can see, it's 2450 megahertz or 2.4 gigahertz, and that's also something very familiar, 2.4 gigahertz. So let's go to the living room. So actually our Wi-Fi routers operate on a very similar frequency. Like this router, for example, operates on 2 bands. It operates on a 2.4 gigahertz frequency and a 5 gigahertz frequency. So that's why if you've noticed, sometimes if you're microwaving your food or microwaving whatever, really, it could interfere with your Wi-Fi connection because they operate on similar frequencies. And then you might be wondering, oh, okay, so why doesn't the router cookie you then? It's like if the router also emits waves, which we get on our phones and our laptops, and we use that, why doesn't it cookie you? Well, that's where the power difference comes in. So the microwave emits 1000 watts, as we previously saw, but your Wi-Fi routers only emit about 250 milliwatts. So it's considerably small compared to what your microwave emits. So the power difference is the reason why your microwave oven has shielding, like it has a case and everything, but then your Wi-Fi router is just as is, because the power output is so low that the waves won't actually affect you in any way. Okay, that's enough for this. Let's watch some TV. Okay, interestingly enough, something really cool here is the technology behind the communication between your remote and your television. Your remote actually sends infrared signal. So remember how we talked about that as one of the subgroups of the spectrum. It sends infrared, and then your TV decodes that signal into some kind of command, maybe to increase the volume or whatever. So a nice way of seeing this, actually, everyone can test this. Get any remote controller and then point it towards your camera, right, like so. So something really interesting about this is that when you press any key, you see this flash, this purple light that flashes towards the camera. It's interesting because if you try to look at that same light, this one, without the camera, you won't see it. That's because our phones can pick up some amounts of infrared light. It should be red instead of purple, but then our phones aren't necessarily optimized to pick up this kind of light. So that's why it's purple instead of red. So yeah, very easy to test. Do it this way. You should see this light, and you can do it in different angles and see how it goes out. So you can't see it this way properly because it's spreading, but you can see that purple flash there. Then if you point it towards you, you see it going straight towards the camera. And depending on the button you press, the information is different. So that's so the number of times the infrared is being emitted changes, and the rate at which it's being emitted changes, and that's what your TV picks up to the code or what the user is trying to do. Yeah, so I think that's cool. Oh, something else I haven't just noticed is, you know how I've been talking about the electromagnetic spectrum. Light itself like what we refer to as visible light, also has a spectrum. And now when I turn off my TV, like when I turned it off, you can see now on my TV the different bands of visible light, because white light is actually the grouping of all those individual colors you see there. So all those combined is what we see as white light. So the last thing I want to talk about is cable TV, right? So like the TV you get from your antenna, right? So this, I also have an antenna here that gives me cable. So it operates on the same principles, the same idea. There is a satellite all the way in Quebec, somewhere in Quebec, that sends radio waves, right? It broadcasts radio waves because radio waves are one of the longer ones, so they can go, they can stretch over like really wide ranges. So when those waves are broadcast, this antenna can pick up those radio waves, or as we've been calling it, the information, and then it transforms that to the digital information that my TV can then show me as video or audio. The same idea with like the radios in your cars or your handheld radios. And then for making phone calls, that one also operates on microwave technology. And then everything is really fast because all the waves, like the spectrum, moves at c, which we refer to as the speed of light. So ultimately, at the end, why even care, right? Like why talk about this? It's like my reason really is just to appreciate the fact that first of all, like these concepts, these principles have always been here, like since how many over 3 billion years ago, when our sun was formed. There was always this spectrum being radiated outwards from the sun to the whole solar system, right? And then common man, like what we refer to as Homo sapiens, have walked the earth for over 200, I think about 300,000 years, right? You can always check that. And then it's just recently, in this past few hundred years, that we've been able to completely utilize this information, this concept that have always been here all this time. So like it makes you think, like if something has been around for so long, we're just able to utilize that, then what's in store for the future? Oh, and yeah, if you have any questions or corrections or anything, really, just get back to me wherever you saw this video. I'm always down to discuss. All right, bye.